What we said is the etcd is one of the essential component of the Kubernetes cluster, which store all the information about your Kubernetes cluster. It holds nodes, pod, all the configuration, secrets, account, role, binding, etc., etc. Right? Every information, right? Every information you get about your Kubernetes cluster, it comes from the etcd itself. Right, after some time you will come to know when you are setting some of your nodes, or you are using some another mechanism to connect with your Kubernetes, so you will be connecting to the Kubernetes using the kubectl command, right? So when you run the kubectl get pod, get nodes, every detail, right, you pull from anywhere about your cluster, you get them from the etcd. Remember it. If you see here, this kubectl is basically pulling your data. So we'll discuss more, right? So every change you make in your cluster also, अगर आप अपने Kubernetes cluster में कोई भी change कर रहे हो, let's say कि आप कोई node add कर रहे हो, आप कोई deployment कर रहे हो, कोई replica set बना रहे हो, आप कुछ भी अपने Kubernetes cluster में update करते हो, तो it updates in the etcd first, only then your change is called to be considered to be a completed. Right, so that's what I said. Etcd is one of the essential component where it stores all the data of your Kubernetes cluster. Anything you make changes in your Kubernetes cluster, adding node, removing node, that is written into the etcd database. The next component, guys, is called a API server. Right, I would call it the API server in the Kubernetes cluster is called the primary management component. राइट, अगर आप यहाँ पे देखोगे kubectl लिखा हुआ है, दैट मींस अगर आप यहाँ पे नोड पे बैठे बैठे kubectl चला रहे हो, तो first this kubectl will interact with your API server. That's what I call, this is the primary management component, right? And one more, guys. Okay, so I said this is the primary management components, means whenever you are trying to, the client is trying to access any data from the Kubernetes cluster, so the request will come to the API server. The API server is responsible for authenticating that request, validating that request, then pull the data from the etcd server, I mean from the this etcd database. So whatever the response will come, then it will provide to the client node, right? Even I would say we do not it is not necessary to run the commands kubectl only to pull the data from here. We have many APIs to do for that, right? So if I talk in general, so API server is responsible for authenticating your users, validating the user request, retrieve data, update etcd database when needed, whenever you are making any changes, and it is responsible for scheduling the things and communicating with the scheduler, and it is also responsible for connecting with the kubectl, provide the information when retrieved. Right, I would call it, there is only one API server in the Kubernetes cluster who can directly interact with the etcd. No other component in the etcd, I mean Kubernetes cluster, can directly communicate with the etcd. Remember it. So only the API server is able to communicate with the etcd directly, guys. Remember this. Any questions so far? Okay, so far, guys, we have talked about two components here. First is etcd, the second is API server, right? The third, guys, we're gonna talk first about the controller manager, then we will talk about the scheduler, right? I would call it, guys, the controller is like a, have you ever seen any ship or any office, right? Let me take the example of one ship here, right? Let's say couple owns one ship, right? What is the responsibilities, right? Let's say in ship you have multiple departments, right? Let's say one department take care of all the ships coming, right, and uploading the containers on the ship, right? One department in that ship is responsible for, you can say, monitoring if everything within the ship is going fine, right? And one department is responsible for, like, see if something in the ship has damaged, right, and repair it. And let's say one department in that ship is responsible to see when the what is the arrival time, what is the departure time, for that specific things. Okay, guys, sorry for the delay. Right, so we was talking about controller, right? So what we said is controller is like a, you can say, office or a department in a mastership, right? That's basically, there is a set of responsibilities, such as, we can say, the office for one ship would be responsible for monitoring and taking necessary action about the ship whenever the ship arrives or leaves and, destroyed. Let's say we was talking about another ship, right? Let's say the another office in that ship is responsible for to see if there is some damaged ship, something damaged in the ship, right? And if something added to that ship and something like that, right? In the same way, guys, we can have multiple departments, right? In the same way, right, the control cube, right, in the Kubernetes terms, right, a controller is a process who continuously monitors the status of various components within the system, right, and works towards bringing your whole system in a desired state, right? For example, right, within this controller, guys, you will see many controllers. So let me go to the document and show you that here, right? You see, we have a cube controller manager, right? And inside this cube control manager, we have multiple components here, right? These controllers include node controller, right? What is the responsibility of node controller? Responsible for noticing and responding when nodes go down. अगर कोई भी node down जा रही है या कोई भी node add हो रही है, right? The node controller will take the responsibility of that, right? In the same way, right? So a couple of things we will discuss more about the node controller later also. In the same way, we have a replication controller, right? And the replication controller is responsible for maintaining the correct number of ports of every replication controller object in the system. Endpoint controllers populate the endpoints object. That means the replication controller will make sure, let's say you have given there should be 4 container always should be running. So the replication controller will make sure always, the number of control ports are running and replicated all the time, right? In the same way, we have couple of another cloud controllers, right? Service and account controllers, which is basically used to manage your API access and token. In the same way, we have cloud control manager. You have to go through these things, right? We have node controller, basically, which is keep on checking if the node is running or not, right? If the pod is running or not. So many things inside the container you will see there. In the same way, we have some replication controller also, right? Replication controller is responsible for monitoring replica sets also, and that the desired number of pods are available at all the time within the system or not, right? That will be taken care by the replication controller. So in the same way, we have n number of controller in the system. Let's say we have a deployment controller, we have a namespace controller, we have cron job controller, we have job controller, we have PB protection controller, service account controller, stateful controller, replica set controller, node controllers, right, and replication controller. So we have so many controllers available in this ship, which are basically responsible for managing everything. Any questions so far, guys? No?
No, sir.
Okay. In the same way, guys, we're gonna talk about the last component, which is called the scheduler or a cube scheduler. Basically, the cube scheduler is responsible for deciding which pod goes in which node, right? It doesn't actually place the pod in that node, right? That is the job of the kubelet, right? This is the kubelet. Do you see, guys, in every node, right? In every node in the cluster, we have kubelet, which is called the captain on the ship, right? This captain basically you can say this captain who is available all on the ship, right? Who creates pod on the individual nodes, right? So that's what it is called, right? Captain on the ship who creates pod and decide where the nodes will be or the pods will be placed, right? Scheduler only decide which pod goes where. Scheduler क्या देखता है? Scheduler सिर्फ ये देखता है कि कौन सा कंटेनर कहाँ जाएगा, कौन सा pod कौन से नोड में जाएगा आपके Kubernetes क्लस्टर के, right? But the kubectl creates those pods in the node, those containers in the node. Remember this, right? So let's say we talk why this cube scheduler is needed, why we need this cube scheduler here. Let's assume you have many ships and many containers, and you want to make sure the right container ends up in the right ship, right? आपको ये देखना है आपके पास बहुत सारी शिप्स हैं, राइट? आपके पास बहुत सारे कंटेनर्स हैं, आपको ये डिसाइड करना है कि कौन सा कंटेनर कौन सी शिप में रखना है, बिकॉज बहुत से टाइम ऐसा हो सकता है कि ये शिप ऑलरेडी फुल हो और ये भी ऑलरेडी फुल हो और इसमें स्पेस हो, राइट? सो who will decide? The scheduler will decide कि कहाँ पे किस नोड पे जाना है, right? तो scheduler क्या करेगा? Scheduler will check so many things. It will check the hardware assessment, whether where we have available hardware in this node, in this node, in this node. It will check the availability of the hardware. On the basis of that hardware, it will instruct, okay, launch those pod in this specific node, right? But those will be launched by the kubelet itself. Any doubt, guys, on this? That's
No,
basically
sir.
that's basically to understand this. This is basically size. All thing depend on the size. It may be like the size of this node is smaller, and this is which you can say it has some more CPU and other capacities. It has less. So everything is evaluated by the scheduler itself, right? The scheduler will check everything here, whether we have hardware available or not. On the basis of that, only scheduler will instruct kubelet to launch the pods on that specific system. It basically does similar like a cluster also. You can say it filters the node, it ranks the node, right? When it filters the node, that means it will see, okay, this is the node, right? This cannot be used. This is the node, this cannot be used. Okay, this is the node, it can be used. It will rank this node and will launch the container here. So these are the basically called a master components. Master components are etcd, API server, scheduler, controller manager. etcd is the database which keeps all the information about your Kubernetes cluster. API server is basically responsible for authenticating, validating your request, and write anything, whatever changes are being write to the etcd database and pull the database from etcd server. It is the responsibility of the API server itself. Scheduler is the component which is responsible to see in which node the pod will reside. It will do it on the basis of, you can say, uh, filtering node and ranking node. It will see in which node you need to launch the container and what is the rank of that node, right? But it doesn't create the pod. This is the responsibility of the kubelet, who is called the captain on the ship, on the worker nodes. The controller manager is basically responsible for monitoring and managing the whole cluster. It has further multiple components like replication controller, uh, you can say node controller, which is responsible for looking into how many nodes are added, how many nodes are removed, so on and so forth. It also manages the replication control, which makes sure the nodes are being distributed, accordingly to all the nodes. It has so many other controllers, so you can go through the documentation and see that, right? Okay, so we can talk the another component which are called the node component. Make sure you are not launching your container in the master node, and this is not recommended in the Kubernetes. So all your pods will be launched in the, I would call it, in the nodes itself, in the worker node, right? So the first we will talk about, guys, are kubelet, right? We have already discussed the kubelet is called a captain on the ship. This is basically a captain, right? Who is basically responsible for creating the pod, who is basically responsible for connecting to the Kubernetes master server. You can say the kubelet, this captain has, sole, relation with the Kubernetes master server, right? It is basically, it does all the paperwork for, who, if I say in the simple words, the kubelet is like a captain in the ship, right? They lead all activities on the ship. They are all responsible for all paperwork necessary to become the part of the cluster, right? They are the sole kind of contact from the master ship, right? They load and unload containers on the ship as instructed by the scheduler, right? So whatever that means, any container, right? If I want to be the part of this cluster, so the paperwork would be done by this kubelet, whether I am like eligible to be part of this cluster or not, right? So this will be done by the kubelet itself. So I can say they are also sent back reports at regular interval on the, stack of ship and container on them, right? Whatever the status of the node we have at this moment, right? They also send it to the Kubernetes master cluster in some specific time interval, right? The kubelet in the Kubernetes workers node register node with the Kubernetes cluster. When it receives the instruction to load containers or pod on the node, it requests runtime Docker engine, maybe Docker, or it may be, something to pull those images and run those instances over the nodes, right? That means whenever, right, it is getting instruction from scheduler to run pod on this node, right? It tells this runtime. Runtime may be anything. It may be Docker or it may be some another runtime, right? It will ask them to pull those container here and run those pod here or run those container in this node. If you see, guys, in general, right, why kube proxy is needed and why it is essential and how it is helping you. ठीक है, अगर मैं बात करता हूँ कि आपने आपने कंटेनर्स लॉन्च किए, राइट, एंड योर कंटेनर कैन कनेक्ट ओवर द आईपी एड्रेस विद ईच अदर, राइट, बट आपको पता है कि इन कंटेनराइज्ड एनवायरनमेंट your IP, your containers would be deleting frequently and your new containers would be generating every time, right? Let's say your application server connects to your database frequently, राइट, क्या हुआ, मेरा एक कंटेनर था, मैंने ओके आईपी व्हाइट लिस्ट कर दिया, ओके आई विल गेट रिक्वेस्ट फ्रॉम दिस आईपी टू दिस डेटाबेस, राइट? अब क्या हुआ, ठीक है, डेटाबेस से आपके पास रिक्वेस्ट आ गई, एप्लीकेशन से डेटाबेस के पास रिक्वेस्ट आ गई और मेरा वो कंटेनर एक दिन के बाद डिलीट हो गया एंड माय न्यू कंटेनर वाज जनरेटेड एंड इट गॉट न्यू आईपी, would it be able to connect to the database? No, right? Because the IP is being changed frequently. So in Kubernetes we have a service concept, guys. What this service does is, right, instead of connecting each container using the IP address, we connect to all the containers, all the different application using the service name instead of a IP address, right? We say, okay, this IP, this web server should connect with this service name to connect with this database. So what it will does is, next time a new container is generated, let's say 10 web server are generated. So these 10 web servers will use that service name to connect with the database, right? And the IP will be automatically mapped to that service, right? You created DB service. So the next time web server just have to find for the DB service name, not the IP address, and connect to the database. Even those 10 servers deleted now and new generated. So next time they will try to easily, if they want to connect to the database, they will use that service name instead of the IP address, right? That's what a Q proxy does, right? This helps you, right, to like the IP address frequently being changed and deleted, right? This can help you to, save your time and connect each pod with another pod using the service name. Make sense, guys?
Sir, I have a question.
Yes, please.
So, sir, I have to.
So that's what we said, guys. It would be like better way for application to connect to the database using, I will call it service instead of IP addresses, right? So to create a service to expose the DB application across the cluster, right? And the web app now can access, you can say that database service name, of using the service name itself, right? Also remember it always, the service also gets IP address, right? Whenever the pod try to reach out to that service using the IP address or name, it forwards the traffic to the backend pod database, right? Because escape further, it, something is working behind it, like IP tables and something. Some rules would be created with this proxy, which will be redirecting your traffic to that specific pod. Also remember this. Also remember, like, this service is not the actual thing, right? This is the kind of virtual things that we can see here. Any questions so far, guys? Also, a couple of things, as I have already explained it, right? So whenever like new service is being created, so that's basically, helping request to like search for that specific service also.